Nice to see you all. It's great to be amongst a manufacturing crowd. I apologize for my outrageous British accent. I can't help it. It just is what happens. I speak at different events all around the world. I speak to different industries, and I'm always most excited to talk to the manufacturing industry. Because to me, I worked for Intel, massive manufacturing company, for 30 years of my life. Manufacturing is where the rubber hits the road. You make the world happen. You make stuff, and that matters. So manufacturing matters really resonated with me this morning. I'm delighted to come and talk to you about manufacturing. I'm not particularly a deep expert on manufacturing. What I do know, though, is technology. And for those of you lurking in the back, there's business class seating in the front here. So please, I promise I'm not a spitter when I speak. You'll be fine if you want to come and sit in the front rows. So manufacturing is going to change the way that the entire world is going to change because of new technology. And that's what I bring as expertise. You might think, well, what is a futurist? That's a weird thing. A futurist, it's a real job, apparently. What it means is I am modeling what will be possible in a certain time frame by looking at how trends come together. So technology trends, of course, business trends, and most importantly, people trends. What do people want? What makes them tick? What are their relationships? What do they care about? What are they afraid of? And importantly, how will they work? How will they work together differently? So that's what I do for a living. What I've brought you today is a glimpse into where is manufacturing going to go in the next decade. And I think we're going to see more change in every business in the next decade than we have seen in the last 40 years. So buckle up. Now, mostly I'm bringing you examples today from the manufacturing sector. Sometimes I'm going to stray outside that, just because I want to give you a feel for just how much change is coming. So Tim, we are going to talk about flying cars just for a minute this morning, just to give you a feel for how quickly this stuff is coming. So let's start off with the big picture. And the big picture here is that the digital world that we know increases in capability exponentially is becoming ever more intimately connected to the physical world that we live in. That means that more value can stream across that bridge from the digital world into our physical world. Now that's happening because there are 6 technologies that are maturing all at the same time this decade. And together, they are going to change the way that we live, work, and play. And the structure of what I'm going to take you through this morning is to walk you through each of these technologies, explain them at a basic level, and then give you some feel for why those things are important and why they're going to be amazing tools that you can use to transform what you do. And what I want you to take away from today is that this is a really exciting time to be in manufacturing, because you've got some really cool stuff coming that's going to help you address some of the issues and challenges you have today, and it's going to take what you do to the next level. So we're going to talk about each of these technologies one by one. Some of them I'm going to spend just a little time on, some I'm going to give a bit more detail to. But hopefully by the end of this, you'll have a real feel for where things are going next. Let's start off with 5G and satellite networks. 5G, you all have 4G today on your phones. It's one more G, must be better, right? One more G. What you're going to get when 5G comes, 5G is the first cell network that is designed to do things other than connect cell phones. So it is designed specifically, not just to make your cell phone 100 times faster, and it will, 10 to 100 times faster, but also it's designed for connecting industrial things. So it's designed for connecting industrial equipment, it's designed for connecting parking meters, anything and everything can be connected to the internet with 5G. So 5G does a lot more than just make your phone go faster. It's got low latency, so you can start to feel like the internet is closer to you. It's going to enable a whole new set of applications, including maybe allowing you to get rid of some of that wiring in your factory that's connecting machines together in an Industry 4.0 situation, and start to do it using 5G cellular networks. So 5G is coming. It's going to roll out in the next few years, but mostly that's only going to be available in cities. So you're thinking, well, what about in rural environments? Well, layered on top of that, we're going to have satellite networks. So a bunch of billionaires are now racing to see how many rockets they can fire into the air and put satellites into space. We're going to put more satellites into space in the next 5 years than all of human history before it. Those satellites, many of them are for doing communications. So they're going to be low Earth orbit satellites. They're whizzing around the planet. They work in this network so you can send a signal up from one city, goes to a satellite, bounces across multiple satellites, and then down to Earth again. That is much faster of a connection than going through a fiber optic cable, because information runs faster through the vacuum of space than it does through a fiber optic cable. So these networks are going to get put in place. Goldman Sachs and other big companies like that will pay for them because they want to have those fast connections between their trading desks in London and New York. But the rest of us will benefit, because what this is going to mean is you'll be able to get a connection everywhere on Earth by the end of the decade. That means that the next 4 billion people will be coming online, or can have the access to come online this decade. That's 4 billion potentially new customers that you can reach, and I'll explain how that works towards the end of this talk. So that's networking. Connecting anything and everyone, everywhere by the end of the decade. Let's talk about the big one, artificial intelligence. Now, before we get into what this is, I just need to get something out of the way. Because when you think about artificial intelligence, you know, your sphincters start to pucker up a little bit, right? Because we've all seen Terminator, and I love my movies. I was talking to Benny about movies and TV shows last night, and there's nothing as exciting as seeing a Terminator crushing a human skull, or Neo, fighting his way through the Matrix. It's all great stuff, but it's not real, right? Hollywood does not make utopian future movies because they're not very exciting. If Arnold Schwarzenegger dropped out of the future and went, "Hello, how are you? Could I like a cup of tea?" It just doesn't, it's not an exciting movie, right? So Hollywood has made all these movies, and they have done a number on us. So I invite you this morning to not be afraid of AI. We should be cautious about it because it's a very powerful technology. We should be mindful about how we use it, but please don't be afraid of AI. Recognize that all of the science fiction that you've read and all of the stories you've seen in the movies and the TV shows, they're entertainment. And they're good to make us think about these things, but I want to give you something else to think about. As I look out at this room of 400 or 500 people, there is a good chance that somebody in this room will have their life saved, or the life of your child will be saved by a medication that is co-developed in partnership with an AI in the near future. AI is a big deal. It's a very powerful technology, and it is going to be great for us. We have to be cautious, but remember, think about the balanced picture here. AI is going to be a great tool for you in manufacturing as well. Now, to give you some feel for the scale of how important I think AI is, I want you to think about your great-great-great-grandparents and what their life was like. Because they lived in a world before there was electricity. Here's a few photographs of what it was like before electricity. On the left side, there's a photograph of, that's a refrigerator. Came as a giant block of ice. In the middle there, that's a washing machine before electricity. On the right-hand side, that's an image of an HVAC system. Electricity changed the way we live our lives. I believe that artificial intelligence will change the way that we live our lives as much as electricity changed the lives of our great-great-great-grandparents. It's that big of a deal. So why is AI different? This is as technical as I'm going to get today, but I just wanted to let you know that it is a different type of computing. Traditional computers, you run programs on them. There's an input-output. If I hit Control-B, the text on the screen goes bold. If I hit Control-S, the file saves. That is rules that are stored in the program that decide what happens when I have an input. AI is different because AI, you don't program it. You train it. You give it examples. You give it input and desired output, and you give it enough of those examples. Eventually, the way that AI works, it will come up with its own rules. So you show it enough examples of pictures of puppies and cats, tell it which ones are puppies and which ones are cats. Eventually, it will figure out, when you show it a new picture, how to figure out whether that's a puppy or a cat. The reason I'm telling you this AI enables us to solve problems that we don't know how to solve ourselves. That's the key thing to know about AI. And it lets us do things like machine vision, because we don't know how to program that, but an AI, we can train it and it'll do that, solve that problem for us. So once you've built these models instead of programs, it lets you do some really interesting things. It lets you do machine vision. It's giving computers the ability to see, hear, and to some extent understand the world. The natural language capability when you talk to your phone or an Alexa or a Siri, that's artificial intelligence at work. It also enables you to create these ideas of super sensors, sensors that can see the world, allow us to see the world more fully. I'm giving you an example of that as well. So lots of things that AI can be used for. It's an incredibly powerful tool, and it lets us solve some really interesting problems. Fundamentally, it enables us to do a couple of things in the workplace. First of all, it allows us to continue to automate tasks. This is something we've been doing for decades, using robotic systems. We're going to continue to be able to do that, and AI lets you do more sophisticated tasks and automate them. Perhaps more interestingly, it lets us augment our own talents, augmenting our creativity, augmenting our intuition, augmenting our strength. It enables us to take the human talent that we have in our organizations and augment them so they can do more, they're more capable, and hopefully they enjoy their work more because they're more able in the workplace. So we'll come back to that notion towards the end. Let me give you a few examples in the manufacturing world. Landing.ai, it's a company set up by the former director of the Google Brain effort, Andrew Ng, and he created an AI that's a QA. So it's able to do quality assurance just by showing it 6 examples of good and bad devices. It's able, with a camera, to learn and be able to do QA for you very, very quickly. Here's another example, and this one's going to creep you out a little bit. This is more on the design side, but design for manufacture. I work with a company called Autodesk, you're probably familiar with them. They make CAD products, computer-aided design products. If a designer is building an angle bracket, maybe it looks something like this, to connect multiple pieces of metal in a structure. AI has now been used in a process called generative design. This is an AI that is designed to work alongside a human designer and collaborate with them to help them do better. So these generative design tools, which have been pioneered by Autodesk, they take that original design from a human and then riff on it and come up with many, many different versions of that have the same functionality but look a bit different. And then runs those through simulation to figure out a design which has the same function but maybe is lighter weight, has more tensile strength, or whatever design characteristics you're looking for. And you end up with designs that look something like this. Super organic looking, like they've dropped out of a scene from Alien or something like that. Designs be made on a 3D printer. I've got a short video here to show you what this might mean. This is from the former CTO of Autodesk explaining this notion of generative design.
What if instead of drawing what you already know, you can tell the computer what you want to accomplish? For example, say I want to design a chair. Instead of drawing a chair and then playing the form, I can instead tell the computer that I want a chair that can support this much weight, weigh this much, and cost this much, and produce something based on the material that I've chosen. The computer can then deliver me thousands, if not millions of design options, all of which meet those criteria. And from those options, I can pick the one design that delivers on the most important criteria. And the one that I select might not even be the one that I could imagine on my own. That's the promise of generative design. But why is it important? It's an entirely new way of doing things, and the benefits are potentially staggering. Unprecedented reductions in costs, development time, material consumption. The sky's the limit. And when we combine generative design with the emergence of new forms of manufacturing like 3D printing, we suddenly have access. Traditional manufacturing methods require you to make massive numbers of something just in order to be profitable. Small designers without access to production resources were simply out of luck. But now we can do a batch run of just one. The stage is being set for the re-emergence of local manufacturing. What does this mean for the designer? Now they will co-create with the technology, choosing the constraints optimized way of achieving those goals, it's going to lead to astounding results. And that's generative design.
So as a futurist, I'm always looking for early signals of how a technology is going to show up in the world. This is an early example from design. I think you're going to see this generative design capability spread to all different types of work. I'm starting to call it collaborative AI, AI that is specifically designed to collaborate with a human and make them better. Now, when Autodesk rolled this out, they were expecting that designers would tell them, yeah, I was able to design 5 widgets this week instead of 3. What they found was, yeah, that was true. But in addition, the designers reported that they felt more creative, that this had helped to liberate their creativity, because instead of exploring 2 or 3 design options for a particular design, they were able to explore hundreds or thousands of options and then pick the one that worked best for them. So it's a really interesting time. It's also been used in architecture. So you're starting to see these really cool-looking buildings that are incredibly efficiently designed because an architect has partnered with an artificial intelligence. Now, if you take AI and you put it into a machine, you get an autonomous machine, everything from robots, cobots, drones, self-driving cars, and so on. So let's spend a few minutes talking about autonomous machines. This is what robots used to look like. They lived in their factories and they had to be trapped inside cages because they weren't safe to be in the same environment as humans. This is what robots look like today. So I'm seeing robots in every industry that I work with. They're getting a lot more capable because artificial intelligence is giving them the ability to see, hear, and to understand the world in increasing detail as they go. I want to pick out a few of the examples from that video just to give you some context. And to say that these have unintended consequences. When you bring a robot in to do what a human used to do, you don't always get just a simple replacement. This is a valet robot called Stan from Stanley Robotics. It's on trial in London Gatwick Airport right now, parking cars. Now the benefit of Stan is you don't have to open the car doors because it just lifts the car up. Human can't do that. So you don't need to secure, the car stays secure, and the benefit is you can park cars much closer together. And when land is at a premium, as it is around London, this is a big, 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 big deal. This is not just about replacing labor, it's about increased land use. You saw Sam 100, the masonry robot. Average human being, if they're any good, As a bricklayer can lay about 500 bricks in a day. SAM 100 can lay 3,000 bricks in a day. But SAM 100 is a cobot. It's a collaborative robot designed to partner with a human. So the two work together because SAM 100 is messy. The human still has to come and strike the wall and get all the mortar off it. So the two together are 6 times as efficient. You saw a universal robotics robot out there. 25% of robots in the future are estimated to be cobots, designed specifically to collaborate and work in partnership with humans. Some of the robots I'm going to show you today are way out there. This is an example. This is a robot in Japan that is being designed to hang drywall. Check this out. They even gave this robot additional joints so that it can do things that humans can't with their arms. And the drywall's done. So that is an experimental robot. I'm showing you the video when it worked, right? There's plenty of videos out there of robots just falling over and freaking out. So we're not there yet. That's not ready for prime time by any means, but it gives you a feel for where it is going. And within 5-10 years, that capability will be reliable. We'll be able to deploy those to do really interesting things that we have to do as humans today. And also, dexterity of robots is improving. You saw in the video this robot rotating and manipulating this cube. A technique called reinforcement learning allows an AI to learn how to do that in a simulation, equivalent of practicing for 100 years. And it's going to make robots much, much more dexterous than they have been in the past. Robots are also getting to be able to learn how to pick things up. There's been a real problem. You have to place things in just the right place so the robot knows where to pick it up. Visual systems and also intuition, so that a robot can figure out from a product it's never seen before how to pick it up and manipulate it, are making big bounds. So this is a short video I'm going to show you that shows you a robot that has been taught how to pick up shoes. And it's learned to classify shoes and to visually figure out where is the tongue and how do I pick that up. This is in a lab. They're still figuring this out. And you can see in the bottom left corner it says 8 times speed. So it's pretty slow. But again, over time, this is going to get a lot better. So robots will be able to do a lot more and understand objects and how to grasp them, how to manipulate them. There are even robots being taught how to pick up mugs by the handle and how to pick up eggs without squashing them. So all sorts of interesting robotics that's coming using AI to turbocharge their abilities. You're, of course, seeing robots in warehouse environments to work in partnership with humans to help them carry stuff around. This one is a beast. It runs for 9 hours on a single charge and can carry 1.5-ton loads around a factory. A company called Seagrid is doing fully autonomous forklifts that can go and pick up a load one side of a warehouse or a factory and then safely take it to the other side of the factory. This is a gigantic house-making robot. It's essentially a 3D printer. It comes from a company called Icon. They built this entire home, 650 square foot tiny home, in 24 hours for $4,000. So 3D printing is going to change the low-cost housing and construction industry too. Now, if you take a robot and you put 4 seats inside it and give it 4 wheels, you get a self-driving car. Every one of the major car manufacturers is now in a race to the death to make the leap to autonomous, because they're going to be moving from selling a product that people buy to a service that people use, which is largely a software-based product. And all of those companies are racing because they know that things are going to transfer pretty quickly. This chart here, the blue area shows dumb cars, so cars that can't drive themselves, you have to drive them. The gray area shows fully autonomous cars, level 4, level 5 cars, that are able to drive themselves. You can see in the 2030 or so timeframe, see if I can get this right. Oh, there we go, fancy technology. In the 20 or 30 time frame, that's when the price of a dumb car versus a smart car becomes close enough that why would you ever buy a dumb car again? So by 2040, the majority of cars being sold and many of the cars on the road are fully autonomous, and they're in fleets. They're not owned by people. They're a shared resource. So autonomous cars are going to happen very, very quickly in the grand scheme of things. But trucks are going to happen even faster. The average car is on the road 13 years before it goes to the crusher. The average truck has only a 5-year life cycle. And there's a lot more incentive to do a self-driving truck because of the legal driving limits that are in place. So all of the trucking companies are racing to also create these self-driving trucks. So look for that, the transportation network over the next 20, 30 years, including shipping, trains, all of it, to start going autonomous. In the delivery networks, UPS is out experimenting with delivery drones. They're out in front, and certainly out in front of Amazon. And you're seeing these drones starting to do real work. They're not just flying cameras anymore that take great shots when you're on holiday. They're being used to do real work, including construction sites, scanning the construction job and comparing it against the digital plans and looking for any tolerances that are out, so that you can fix issues on site before you start putting in plumbing and electric and then realize that the walls aren't in the right place, for example. So drones being used for lots of things, including there are now apparently drones for dogs. I used to teach presentation skills. I used to coach people. Make sure there is at least one puppy in every one of your presentations. So there you go. This is this morning's puppy. Now, if you can build a drone for a dog, could you not scale that up and make a drone for humans? Well, the answer is yes, you can. I'm tracking over 100 companies that are building what is essentially, this is Tim, this is your flying car from the Jetsons. Right? They're very different. They're just scaled up drones, but they're completely electric, vertical takeoff and landing. They're much quieter than helicopters, thankfully, and much safer than helicopters. You can lose up to 3 rotors on this particular one, and it will still safely come to the ground. There are about 20 or so companies that I think have a viable path in this area, and look at the names on here. Embraer, Airbus, Boeing, Uber. There's serious money being invested in these, and behind some of these startups, the companies you won't recognize, there's money from Toyota and Volvo, and the big car companies realizing they have to be in this game too. Uber has long-term plans. They would like to be able to deliver fully autonomous flying car services. And their goal is that on a per-mile basis, it will be cheaper to fly in one of these than it is to drive in a gasoline car today in 2020. This is not going to be, an elite service for the rich only. This is something we will all have access to. First commercial services, likely to launch maybe Dallas, LA, certainly Dubai, Singapore, in 2023. That's just 3 years from now. Now, I'm telling you that this has nothing to do with manufacturing, but I want you to understand the scale and the pace of change that is happening everywhere else, and this is also coming to the manufacturing world. So we're going to see, as cities change, as you're able to move across town and avoid ground-based traffic by taking a flying car. So 3 years from now. Let's talk about the Internet of Things, next technology. This is the idea that you make objects and infrastructure smart and connected. This is happening because computing got small and cheap. I worked at Intel for 30 years. Computers now, this computer here has about the computing capability of a laptop in the mid-90s. It costs $5, and as you can see here, it's smaller than a tin of Altoids. So computing got cheap, and it's got small. This is a less powerful computer, but in this picture here, this computer is resting on the edge of a 1-cent coin. They go smaller still. This is an effort from IBM. This particular computer chip is smaller than a grain of salt. When it goes into production, IBM is projecting this would be available for less than 10 cents per unit. What this means is we can start to stir intelligence and connectivity as an ingredient into any product that we make. What it means is in the manufacturing world, you're going to have to start thinking about products that were traditionally not smart and connected becoming smart and connected. And the reason we're connecting things is because it's a way of putting sensors into the world. SAP, big software company in Germany, they estimate that by the end of this decade, our world will be filled with 100 trillion sensors. That's 8,000 sensors per human being on Earth. There's sensors, everything from cameras, microphones, temperature sensors, moisture sensors, and so on. It enables the digital world to understand what is happening in our physical world and help us out. It's going to enable us to create capabilities that make our physical world feel more responsive to human needs. It's going to lead to this notion of connected infrastructure, connected objects, wearables, and using these sensors to connect 100 billion devices by the end of this decade. And those 100 billion devices are going to need to be made by somebody. Guess who? I'll give you a few examples of connected infrastructure and connected products just so you know what I'm talking about. Starbucks in China connects their Wi-Fi hotspot to their music system. You think, what? What they do is they use the Wi-Fi hotspot to count how many phones the hotspot can see in the store. Usually one phone equals one person. They use the Wi-Fi hotspot as a sensor to figure out how many people are in the store. If it's quiet in the store, they have the music down low, bit of Sinatra, chill out, have another cup of coffee, have a piece of cake, spend more money. If it's busy in the store, there are a lot of people in the store, they turn the volume up, they turn the tempo up, and they get people in and out. Money, money, money. This has had material impact on Starbucks business results in China, just by using the Wi-Fi hotspot as a sensor. This is another business changer. This is a smart connected toothbrush that tells on you to the dentist. So it's connected to your phone, the phone's connected to the cloud, to the dentist, and it measures whether you brushed your teeth properly in the morning and night, did you get in the molars in the back, did you do it for 2 minutes? Because if you do, you're thinking, well, I don't want the dentist to know whether I've been a good boy or good girl or not, right? The reason you do that is because if the dentist knows that you have good oral hygiene, you are at a lower risk for needing expensive dental interventions. This dentist who invented this thing at Beam Dental is able to offer dental insurance for 15 to 20% less than his nearest competitor, because he's able to measure that risk and take on patients who have good dental hygiene. So you're going to see a lot of products that used to be dumb, like your toothbrush, become smart because there is value in that, and it turns products into services that people want. Here's another fun example. This is a wallet that's connected to your bank account in real time. It has a variable strength hinge on it, so that as you get poorer, it becomes harder to open. So you can feel how poor you are and whether you should pay for that new pair of shoes or something. This is closer to home for you guys. There's a whole set of sensors that are designed for manufacturing equipment so that you can sense whether a piece of equipment is likely to need maintenance. So it listens to the sounds and the vibrations made by that piece of equipment. It knows what normal operation should sound like. And if that deviates, it will tell you its best guess on what kind of preventative maintenance needs to be done. So check out that company, Augury. They're an interesting company. So this is an example of taking the Internet of Things and these sensors and adding in artificial intelligence and creating what I call super sensors, the ability for us to see the world more fully, in this case, listening to machinery and figuring out from the sound it's making, yep, it's got a bearing that needs to be changed, or it needs a drive belt replaced, or something like that. Let's talk about blockchain really quickly, and then get on to augmented reality and a few thoughts at the end. How many of you are familiar with blockchain technology? Just a few. It's the most obscure of the technologies I'll tell you about today, but it's also very powerful. It has lots of applications. I'm going to focus on just one of them today. You might have heard of blockchain because it's the technology that underpins cryptocurrencies like Bitcoin. Personally, I find cryptocurrencies in and of themselves pretty dull in terms of their usefulness. Think about it the other way around. Blockchain is the technology, and cryptocurrencies are a way of making them go. And blockchain is something you can build applications on top of, distributed applications. Now, what is a blockchain? Really, at the simplest level, it's a fancy database. That's all it is. People will flim-flam you about, and it is a very complex technology with very powerful, but fundamentally, it is a fancy database. Fancy how? When you put information in the database, when you store information in it, you can't edit it. So it's immutable. That means that it can be used as a source of agreement to say, we recorded this, we know this was true when it went in, you can't change it. It's an agreement machine. It also has this notion of smart contracts, which is going to disrupt lots of the ways that people do business together. But for the purposes of manufacturing, I think the really interesting place this will get used is to build trust in the supply chain. What do I mean by that? If you go out to any great restaurant in America and you order the halibut, you know what your chances are of getting halibut? About 50-50. Because somewhere along the way, something happened. Bizarrely, something got accidentally, let's call it, mislabeled. If you order red snapper in the United States, you know what your chances are of getting red snapper? It doesn't matter how good the restaurant is. Any guesses? 10% is the correct answer. Yeah. So people are getting more interested in finding out what's the food that they've got, where did it come from? And in general, people are starting to ask tougher questions. What's the origin story, whether it's of my food or the product that I bought? Was it made using chemicals that I'm not happy about? How much water was used to make it? How much energy was used to make it? How much energy was used to transport it to me? People are going to start asking about all these questions about products, how they were made, and how they came to their front door. And you're going to see all of this information is going to need to be gathered. You're going to see sensors in manufacturing plants. You're going to see sensors in transportation networks. You're going to see ways of measuring all of this information because consumers are going to start to demand it. So I'm here to give you the heads up that you've got 5 to 10 years to really get this figured out, maybe less. But consumers are going to demand to know much more about the products that they buy. And you're going to get upstream push from the brands, the end companies that you sell to in a few years to start thinking about how do you track this stuff and use blockchain as a way to track that information so it can be trusted. Because consumers aren't just going to demand to know the story, they're going to demand proof. And that's where the blockchain comes in, that immutable database. Not only that, brands are under incredible pressure. I work with a lot of big brands, and they are hurting, right? They've got counterfeiting, diversion, where people, shoe company places an order for 1,000 shoes and the manufacturer runs 1,100 and ships 100 to the gray market. They've got shrink in the transportation networks, inflated chargebacks from retailers. It is an ugly time to be a big major brand these days. So they're also looking to this type of technology to help them get controls over their supply chains. And to do that, one of the functions of blockchain, remember I said blockchains are made go by cryptocurrency, also known as tokens. They can use these tokens as a way to incentivize people to help them. So this may be a moneymaker for you. The idea being, if you put in the sensors needed in your factory to be able to guarantee that you're not running extra product and diverting it and selling it on the gray market, I don't think any of you are doing that today, but this is the stuff that's coming. You get rewarded when you supply that data with tokens, and tokens make prizes, make real money. So it can be another way for you to create a revenue stream. All right, that's blockchain. Blockchain's like a 2-hour workshop I do. I just hit that light, but I wanted to give you that visibility that pressure on supply chains for transparency is coming. Let's talk about one of the sexiest of these technologies, augmented reality. How many of you have tried virtual reality? Just by a show of hands. Okay, many of you. It's kind of cool, right? You're immersed in this digital reality, completely separated from the physical world. You feel like you've been transported somewhere else. This guy is clearly having an amazing time. But VR, virtual reality, to me, it's cool, but it's not the thing. The thing is augmented reality, where you're blending digital objects and images and information into your natural field of vision. So you're not disconnected from the physical world around you. You're still present, but overlaid on that, you can see objects and information as if they're physically there. This is going to transform the way people work and the way people learn, particularly in the manufacturing sector. What it means is that the display, we have these beautiful screens up here you're looking at right now, It means that the display canvas becomes the physical world. You can just put information, objects, digital information anywhere and everywhere. What it means is your next 150-inch TV is not going to come on the back of your truck from Costco anymore. It's going to be downloaded into your glasses as an app for 99 cents. And by the way, you can take that TV with you when you go camping and set it up inside your tent, if you want. It's going to change the way that we think about displays and displaying information. It's also going to be the computing for people who work with their hands. 80% of people work with their hands. They don't work in offices with laptops, or they're in highly mobile environments. Think people in manufacturing, construction, surgeons, retail workers. This will be computing for the rest of us. Computing that we can use our hands, and we're communicating with it through gesture and voice. It's already in trials in manufacturing now. This is a product called HoloLens from Microsoft. They're doing a lot of trials with manufacturers around the world, looking for how it can be used. This is it being used on a production line in a Volvo manufacturing plant. Giving people contextual information about what they're working on right now, or even more, giving people instructions on how to use this. It's also going to be great for collaboration. But the real breakthrough to me is this notion of creating hybrid workers. I know you're having trouble finding good quality workers. Right? It's a big issue in this state, particularly for manufacturing. To be able to have someone come and work on the job and be productive hour one, because they're putting on a pair of glasses that shows them exactly what they have to do. The glasses follow along and help them as they go through step by step. So they're learning by doing on the job in real time. No 12-week training course better use this piece of equipment. Now the training course is a pair of glasses. So being able to show people what to do in the moment is going to change the way. What you're doing is creating a hybrid worker that is a combination of human intelligence, intuition, dexterity, and digital intelligence working together. Let me show you an example of how augmented reality is already starting to show up in the construction industry. This particular example, inspection of construction sites to see how things are all progressing.
Conventionally, the inspection process is done manually, often requiring more than one person. It can take a long time to document and circulate the information to others. SRI's computer-aided system can accurately track user location as they move around a large job site. With instant access to an intuitively searchable digitized database, an inspector is able to accurately align and compare what is being built against the building information model. Manual measurement processes become automated and more accurate. Capturing and documenting data become less time-consuming. The inspector can snap photos on demand or add and retrieve virtual notes that stick to a location, which can be shared across multiple devices.
Pretty amazing way to create a punch list, right? No more blue tape. So just a simple example of taking those 2D blueprints that are still prevalent in manufacturing sites. Even though the buildings are designed with a 3D system and there's a building information model, taking that and actually making it into a 3D way of perceiving the world, changing the way that we work. So we talked through all those 6 technologies. What does all of this mean? It means that industries are going to change. You heard from Missy this morning that we're going from Industry 1.0 up to Industry 4.0. And we've added assembly lines and mass production, electrification and computing, and suddenly cyber-physical systems and artificial intelligence to get us to here, Industry 4.0. My job is not to tell you just about Industry 4.0. I'm a futurist. So let's talk about Industry 5.0. Industry 4.0 created a digital model, digital version of the manufacturing floor, and allowed you to optimize that by using artificial intelligence. What that does is it's sort of taken the humanity out of things. Industry 5.0 is still kind of formulating. People are still arguing about what that will look like. but it seems to be coalescing around this idea of bringing the humans back into manufacturing, bringing humanity and human skills back into manufacturing, and building a manufacturing environment that embraces that and has humans and machines working side by side in a partnership, and doing that with the aim of delivering more personalized products to consumers, because that's what consumers are going to be looking for. Much higher levels of customization and personalization in the future. So that's where we're headed with Industry 5.0. And where we're going longer term than that, I think, and this is really great news for you, is that you can now start to think about accessing manufacturing on the world scale. We already have a funding cloud. Think about Kickstarter, Indiegogo. Innovators can go and get funding from a cloud of people. They can also go out to a design cloud and get help from people to design their products and bring their ideas to life. We're moving to an era where somebody who has a great idea, maybe they're living in a city in Brazil, they're able to find customers through the funding cloud, get help with design, test it inside the brain of a supercomputer, and then go to a manufacturing cloud where they say, who's got spare manufacturing capacity, who's 5-star rated, who is nearest where the customers I have are, print. And that job will come to you and you will make it and then ship it through the emerging distribution cloud. This ability for you to start thinking about producing goods on the world stage for customers who you might never meet in countries you might never go to is a reality that's coming your way. It's an idea of distributed manufacturing. What this means is work is going to change for all of us. As you look at the tasks that you have on the manufacturing floor, this is the job that everybody in every company in America is going to have to go through in the next 5 to 10 years. So look at all of those tasks and ask the tough question. Which of those tasks is best done by a human, and which is best done by a robot or an AI? And how do you use sensors to be able to gracefully hand off between those three? And the reason you do that is because we all have different strengths and weaknesses. The good news is there are more things in the human column than there are in the other columns. So yay, we're not irrelevant yet. But the smart businesses will use these other technologies to augment what we do, to automate tasks and to augment the tasks that humans do. And there's multiple ways we'll augment. I'll give you an example from the manufacturing world. Polishing is really hard to do, but machines are starting to be able to do it. This is a robot polishing machine. It's really hard to explain to a robot when something is shiny enough, it turns out. So building partnerships between humans and machines working together. So the robot starts off with the polishing, does the best job it can, hands off to the human. You use metrology and you use augmented reality to show the human where you need to finish things off. Now you have a true partnership of robots and technology and humans working together. What it means is we're moving to a new era of work. 300 years ago, we would have all been working on the farms. Back-breaking work would have been lucky to live to 30. But then the Industrial Revolution came along, we created mechanical muscles, and we moved many people into knowledge work. We're now, as I've shown you earlier this morning, we're now on the verge of creating mechanical minds. What that means is we're going to commoditize more physical work. You saw some of those robots that are much more capable than robots have been historically in the past. And we're going to start to commoditize also some knowledge work. This is going to push us into an entirely new era of work. The question is, what is that era? I think it is the augmented era of work, where we're partnering with technology, where our relationship with technology changes so that technology is no longer a tool, it becomes a trusted teammate. I've given you lots of examples of that as we went through today. There's some additional ones up here, but collaborative AIs, cobots, digital personal assistants on our phones, exoskeletons to make us stronger. We're going to start to partner with technology in much more intimate ways than we have in the past. Here's a short quote from the Harvard Business Review from Accenture people. Those that deploy AI, mainly to displace employees, will only see short-term productivity gains. Firms achieve the most significant performance improvements when humans and machines work together. So as you think about your automation strategy, think about that. Be smart about how you do it. Don't just try and replace workers. Figure out how you can take the workers you have and lift them up. Figure out how you can use technology to elevate human work, to make it so your workers really want to come in every day and they're passionate about the mission that you have. So wrap this up. I know I'm behind. Every company on the planet, every company represented in this room is now a technology company, whether you have recognized that or not. You're first and foremost a technology company and a data company. The gap between companies that don't embrace technology and that do has always been there. But that gap is going to widen dramatically in this next decade. Work is going to change for good and worse in some cases. But mostly, it's going to improve the quality of our lives and make us enjoy coming to work more. Because the things we don't want to do get offloaded by technology, and the things we do want to do, technology helps us to do better. Be thinking about how to not only automate, but augment your workforces. Think about the need to build smart, connected products like that toothbrush. Think about not just Industry 4.0, but now 5.0. How do you bring humans and invite them back into the workplace and use them to make more personal touches to the products that you build? And finally, in the long term, be thinking about that distributed manufacturing world, where you may have customers that you never meet in countries you never go to produce goods for customers that you never meet. That's an exciting world where you're connected on the global stage. And with the leadership that you have here in Wisconsin, you're well positioned to play a massive role in the future of global manufacturing. Your opportunity is enormous. You may not realize this, but you're in a fantastic position. And this technology is at your back to help you take it to the next level. If this was useful to you, you want to know more about this kind of stuff, I have a book. This is me shamelessly pimping it at the end of my talk. But more importantly, if I can be useful to you, if you have questions, we don't have time for Q&A today, that's my contact information. You're welcome to reach out to me. I'd be glad to help you. I hope this was useful to you. I hope it caught your attention, got you thinking. Enjoy the rest of the day. Thanks, everybody.